Alright, let's see. I think this is, let's see, we left off with that one, right? Did that one? Okay, so we got this one to go. X times y in parentheses to the 6, starting off with an easy one. Oh, gotta know them rules. X to the and y to the, there we go. See, you do know, you're just not awake yet. Okay, that's okay. I get it. It's early. X to the 6, y to the 6. Alright. Now, everything we did yesterday plus this one, we probably should have just powered through and got to this one yesterday, to be honest, but, you know, whatever. Those are the simple ones, okay? Now is whenever we're going to start getting a little bit more tricky, okay? And this is where knowing those rules is really going to help you and benefit you in going forward, alright? So here's the first kind of harder one. Oh, I lied. We got one more. This one is x to the 6th over y to the 6th. Okay. So division of 2, you just take that exponent to both top and bottom. Alright. Everybody good? Now, the harder ones. There we go. Now, yesterday, I had mentioned that these can be challenging. And to me, I think the challenge is in two places. Number one, the challenge is in remembering the exponent rules and when to use them and how to use them. The second place is this. It's not like there's one set way to do these problems. Okay? You can apply the properties in different orders. It's not fully like PEMDAS, okay, where you have a specific order. But what I'm going to tell you guys is this. At each step, let me back up here. At each step, you need to ask yourself these 4 questions. Okay? At each step, ask yourself these 4 questions. And if you don't meet one of those 4, then you have some work to do. Until you can check off all 4 of these, that's when you're done. But until then, your order of what you do isn't fully important. Alright? Because you could do it different ways. Now, that being said, I think there is a nicer, easier way to do it, and that's the way I'm going to teach you. Okay? So for this example here, we have 2a to the negative second times 3a cubed b squared times c to the negative second. At its core, we're doing what? We're multiplying. Okay? So once again, let's do our numbers first, our coefficients first. 2 times 3 times 1 gives us what? 6. Okay? Easy enough. And now let's just continue to multiply. Alright, so we have a to the negative second times a to the third times, there's no a's over here, so we don't care. So a to the negative second times a to the third. Careful. Vocab. If you're multiplying a to the negative second times a to the third. You're multiplying your bases, so what do you do with these exponents? You add them. So negative 2 plus 3 gives you 1. So just a. Then you go to your next variable. I see 1b. So bring down the b squared down here. I see c to the negative second, so we'll bring it over here. So that's your first step, multiply them all together. Now, if you go back to those 4 questions, check on them, you'll see there's one that we don't meet. Which one do we not meet? The negative exponent one, right? This one right here. So to clean that up, we're going to move it from the numerator to the denominator. Okay, and then we're going to make it 6. A, b squared, all over c squared. Okay, so I am going to work this one according to your rule. Alright, now, it's a division problem, yes? Okay, so when we divide our variables, we do what with our exponents? You subtract them, okay? Now, And whenever you subtract them, it always ends up being where you subtract them, you have it end up being on the numerator, yes? Okay, it's always top minus bottom, and it goes to the numerator. So that's how I'm going to work this one here. So you have 2, or cubes, let's do cubes first. Q to the 2 minus 7, R to the 4 minus 3. 2 minus 7 is what? Negative 5. R 4 minus 3 is 1. What's wrong yet? Negative 5 on the exponent, so we move that down. Gives us R over Q to the 5th. And they're done. Now, if that way makes sense, if you just want to subtract that, see what you get, and then move it afterwards, that is perfectly fine with me. Please, please, please do it that way. All right? There is, however, a shortcut. Okay? There is a shortcut. There's 2 Q's up here, there's 7 down here, right? Which means there's more down below. Make sense? So that's where they're going to be. Right? Because if you just write them all out, 2 Q's, 7 Q's, and you go cancel for cancel, 1 for 1, it'll end up being more down below. That's the other way you could do it. You could do 7 minus 2, and since they're going to end up down here, just do it that way too. All right? If that confused you, please just ignore every word I just said and just do it this way. But if that makes sense to you and you want to shortcut it that way, that's fine too. All right? Questions on that one? So let's do the first one. Yeah, negative 2, a to the 4th, b squared, all of that being cubed. Okay. Now, like I said, you always go through that list of questions. All right. Am my fractions simplified? Do I have powers of powers? Are all my bases happening one time? And or do I have negative exponents? Okay, them 4. So if you look at this one up here in blue, your bases all happen one time, right? You have a 2, negative 2. You have an a. You have a b. Okay, so your bases happen one time, so you're good there. You don't have any negative exponents, so you're good there. Your fractions are simplified, so you're good there. The only thing wrong is you have a what? You have a big power. See that big power? His name is 3. Alright, so when you cube it, you got to cube the inside. Since the inside is a fraction, you got to cube the top of that fraction and the bottom of that fraction. Okay? Since the top part of that fraction has 2 parts, you cube both parts. So you're cubing 3 things. You're cubing the negative 2, the a to the 4th, and the b squared. Alrighty? So, do it like this. What's negative 2 times negative 2 times negative 2? Negative 8. There you go. Alright? Negative 8. Alright? Now, once you do that, take each variable individually. What's a to the 4th to the 3rd? So a to the 4th to the 3rd. Power to a power, multiply your powers. What's 4 times 3? 12. So a to the 12th. Now do it to the bottom. What's b to the 2nd to the 3rd? B to the 6th. Good. And that's it. Notice how the 8 is negative. It's not a negative exponent on the 8, so it stays here. See the difference? Let's go to this one I made up. Okay, lots going on here. I always ask myself this question first. Do my bases happen one time each? That's my go-to. Okay, that's where I start. This one, they don't. See how you have A's on top and bottom, B's on top and bottom? So that's what I go for first. Clean them up. All right? Whoops, wrong screen. So, A to the negative 3rd over A to the negative 5th. So negative 3 minus a negative 5, which becomes negative 3 plus 5, which gives us 2. All right? Okay. Now, see this right here? b squared over b to the negative second. You know what the common mistake happens here? It's a common mistake. Think about what it would be. What do you think people mess up with right here? They cancel them out. Because b squared, they see b squared, b negative 2, they're like, oh, yep, 2, done. It's b to the fourth. Because it's 2 minus a negative 2. Okay? So it's b to the fourth. Be ready for that. Alright, you'll probably see one like that somewhere along the line. Okay.
So you have to add that?
So, well, you add it, so you eventually add it since it's negative 2 down here, but it's 2 minus the negative 2. So it's minus a negative. Okay.
Oh, okay.
Alright. Makes sense? Now, the negative exponent. So you do the same thing here. You do your power to power, okay? Now, here's why I handle this. Here's how to handle this. That's a 1 on that power of 2, on that 2, right? Okay, everybody see that? So all of these, you want to multiply these exponents by negative 2. So 1 times negative 2, a to the second times negative 2, and b to the fourth times negative 2. Like that. Since they're all negative, you want to make them all positive by making it 1 over all this. And the last thing to do, square 2. All right, page 233, 16 through 23, 28 through 33.